Hello everyone, welcome to Back to Basics, and today we'll be covering the cast rule. And we'll be using this cast rule to determine the related acute angles and use them to solve specific questions. Now to begin, let's define some terms that we're going to be using throughout this session. First is a ratio. A ratio can simply be defined as a quotient between two numbers. So 1/2 is a ratio. Now, a trigonomic ratio is when we use sine, cosine, and tan to determine a output to their respective angles. For example, sine theta is equal to the opposite over the hypotenuse. This opposite and hypotenuse creates a ratio known as a trigonomic ratio. Now, we're going to go ahead for the terminal arm. A terminal arm determines the angle based on the primary trigonomic ratio, and it has a relation with the initial arm, which starts at the x-axis on the positive side. So if the initial arm is my green arrow over here, then the green arrow will go over here on the Cartesian plane. And then our terminal arm can be any of these arrows, and it creates an angle with the initial arm. So therefore, it creates this angle. We can obviously have this as 25 degrees, for example. Now we always read this Cartesian plane, or the terminal arm, goes counterclockwise. However, it can also go clockwise. However, that'll be a negative angle because it's going in the opposite direction. Now, to begin, we have to understand how this Cartesian plane correlates to trigonometry. Well, if you can see, there's a 0 over here, which indicates that if our terminal arm is at 0 and our initial arm is also there, that means it creates an angle of 0 degrees. So to visually see it, this will essentially be our angle that it creates with the terminal and initial arm. Now, let's say this angle or this terminal arm were to go 90 degrees perpendicular to the x-axis. That means it creates a right angle because it's 90 degrees. Now let's say this terminal arm then goes another 90 degrees. That means it creates a straight angle, or 180 degrees. And if it continuously goes 90 degrees, then it will eventually reach 270. Now when it gets to this part, it doesn't go back to 0. You simply just add 90. So that means this will be 360. And I'll explain the relation between 0 and 360 soon. So now, let's look at the cast rule itself. Well, essentially the cast rule tells us is that these trigonomic ratios, their outputs would be positive within their own respective quadrants. As you can see, I have A, S, T, and C. Let's have a really basic example over here. Try putting sine 25 into your calculator. And do that for cos 25 and tan 25. And see whether your output is a negative or a positive number. So if I go ahead, mine are all positive. So that's why the A represents all of the trigonomic ratios will be positive within this quadrant if the terminal arm lands over here. Now let's look at quadrant 2. It's an S. So by that means most likely sine theta, its output will be positive. Let's check. Try putting sine 120 into your calculator. and then cos 120, and then tan 120 into your calculators and see what output you get. Is it going to be a positive or a negative number? For me, sine was positive. So that's why in this quadrant, sine theta, its trigonomic ratio, will always be positive. Now, why is that the case? Well, if you try graphing this function, y equals sine x, it creates a function, but not a simple linear or a quadratic function, as you may have seen before. It creates a sinusoidal, right over here. So y equals sine x. Now, between, what are the two angles? 90 and 180 degrees. Let's just look at the graph itself over here. Between 90 and 180, we can see y equals sine x is above the x-axis. So that means all of its values, whether you put sine 91 or sine 179, it will always be a positive output. Now, let's see for the other two, y equals cos x. As we can see from 90 to 180, we can clearly see the function is below the x-axis, which means its outputs will be a negative. Now let's go to tan x. From 90 to 180, we can see that the function is below the x-axis. That means its outputs will be negative. Now that's just proving it to you in two different ways. Let's go on to the other quadrants. If you try putting tan 182, and then you do the same for cos and sine, you'll know that tan 182 is equal to a positive output or a positive ratio. And if you do the same for quadrant 4 for cos, let's say cos 298, and you do the same for sine and tan, you'll notice that for cos 298, it will be a positive output. Now all of these, you have to have your calculator in degree mode. If it is in radians, then your outputs will be different. Let's go to define what a related acute angle is. So in a related acute angle, our angle is less than 90 degrees and creates an angle with the closest x-axis in relation to the initial angle. So let's take a look at some of these angles over here. Let's do 121 degrees. So if we draw our initial angle of 121 degrees, our related acute angle has to be less than 121, but it also has to be in relation to its initial angle, which means if I put sine 121 and then sine theta, which is our related acute angle, let's say, or let's pick a different, let's put beta as our related acute angle, their outputs will be both positive as well as having the same numerical value. Now, of course, this will be different for cos or tan due to the Castro rule. However, its magnitudes will be the same. So what I mean is 121, sine 121, and sine beta, or the related acute angle to 121, will equal to the same value. Now, how do you find this related acute angle? Well, a simple step is to look at the number 180. All we really need to do is do 180 minus 121, which will give us our related acute angle. So let's try that. I get 59. So if you put beta equal to 59, sine 59, you'll see that sine 121 is equal to 0.86, and sine 59 is equal to 0.86. So let's take a look at a different example. Let's take a look at 330. So 330, it will be in quadrant 4, because it has to be greater than 270, but also less than 360. So that means 330 degrees is in quadrant 4. Now, to find the related acute angle of 330, we don't actually subtract by 180 or add 180, because that'll simply create an angle greater than 90 degrees. We have to try to find this angle over here, angle theta. And how you do that is simply subtract by 630. So 660, my bad, minus 330 will yield you an angle of 30 degrees. Now that will be your related acute angle for the angle 330 degrees. Now, for each individual quadrant, finding this related acute angle would actually be very different. Let's say your angle is in quadrant 1. So I'm just going to draw the terminal arm. If our terminal arm is in quadrant 1, then we don't have to do any calculations to find the related acute angle, because that angle is already less than 90 degrees, which fulfills our criteria. Now, what if your angle is in quadrant 2? Now our angle is greater than 90 degrees. So to be able to find this related acute angle, we would have to subtract 180 minus theta, which will give you your related acute angle. Theta essentially is this angle over here. And then beta is the related acute angle. Now, what if your angle is in quadrant 3? Well, then you'll simply do theta minus 180, which will give you your related acute angle. And then if your terminal arm is in quadrant 4, you simply do 360 minus theta is equal to beta. Now, using the cast rule, it doesn't really matter if it's sine theta or cos theta or tan theta. You'll simply follow these patterns to be able to find your related acute angle. However, your outputs would be a negative or a positive depending on the quadrant that terminal arm is located in. Now, an easy way to remember this cast rule is we start from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. I like to follow this acronym: all students take calculus. So the beginning letter of each word, A, S, T, and C, essentially represents sine, cos, tan, and all of the angles. Now let's take a look at some questions. So these ones over here.